Welcome to this today's session. In this today's session, we are going to see about one more topic on automata theory. That is NFA with the epsilon, conversion of NFA with the epsilon to without epsilon, conversion of So today we are going to see about this topic only, conversion of NFA with epsilon to without epsilon. So epsilon means that is without input symbols, it can pass from one state to other state. NFA, everybody, NFA means non-deterministic finite automata. So here this we want to delete the epsilon. We want to convert with the epsilon to without epsilon. So say for example now Q0, Q1, Q2, Q3. So actually this is an example for conversion of NFA with epsilon to without epsilon. So here you can see how many states are here. Here 4 states are here, Q0, Q1, Q2 and Q3. So which one is initial state? So Q0 is the initial state because this arrow mark indicates it shows the initial state, and this is a final state. That means it indicated by double circle. In circle the state indicates the final state. Final state means everything should be stored there, right? So here how many input symbols are here? 0 and 1. So 0 and 1 are 2 input symbols. So what about this epsilon? Epsilon is a without input symbols. It can pass from one state to other state. Can pass from one state to other state. So this we want to convert this transition diagram with the epsilon to without epsilon. So now we want to convert this. So here only epsilon is there. We want to convert into without epsilon. So there are 6 steps out there. Okay, step 1. Step 1 here first what we have to do is step 1 is epsilon closure. We have to find about the epsilon closure now. So this is step number 1. So how we can find the epsilon closure now? So from this diagram we want to check the path of each epsilon now. Say for example for each and every state. So how many states are here? 4 states are there. So first you will see from one state by state. So first state Q0. So Q0 you want to check the epsilon state. So we want to make sure that every state it has own a transition, self transition there. Transition, epsilon transition there. So each and every state they are having their own self transition. That means what? So Q0 means it should indicate Q0 also. So Q0 and epsilon goes to where? At the path Q1, and next one goes to up to Q3, right? So this is epsilon path for Q0. So it has each and every state has the self transition of epsilon. So that means Q0, Q1, Q3. So next one for state Q1. So Q1, what is the epsilon closure? Q1 epsilon closure is Q1 and Q3, right? So Q1 and Q3. And next one Q2 there is no any epsilon path, but it has own a self transition. So that is Q2. And Q3 is also there is no any epsilon path, but it has own self transition. So this is Q3. So this is a closure, epsilon enclosure. This is the first step. So first step already finished now. So we are going for second step now. Second step number 2. Step number 2 is we have from this diagram, transition diagram, we want to create a truth table, that is transition table. Transition table. So from this diagram you have to create a transition table now. So how many states are here now? So 4 states are there. So Q0, Q1, Q2 and Q3. So create one table like this. So how many input symbols? Zeros and ones. 2 input symbols are here, 0 and 1. So you have to include epsilon also. Epsilon also you have to include. So now we have to, with respect to this diagram, now we have to create a transition table now. So first this one for Q0. If you are applying 0, so where it goes to 0, which state? Itself, self transition now. So Q0 is Q0 now. And what about if Q0, if you apply 1 to Q0, so there is no any 1, right? So there is no any 1, so it symbol null, this symbol represents null. This symbol represents null state. So there is no any symbol means. Okay. So next one for epsilon, Q naught epsilon goes to Q1. Q naught epsilon goes to Q1. And similarly, like this, you have to fill it up the truth table. So Q1 for Q1, there's 0. So for if you apply 0 as an input to Q1, goes to Q2. And Q1, there is no any one symbol, right? So epsilon. And what about Q1? Epsilon goes to Q3. And similarly for Q2 is 0. 0 there's no any 0. 5, that means null state. And for Q2, if you are applying one symbol means it goes to Q1. And for what about epsilon? There's no any epsilon path. So it's null state. And similarly for Q3 is 0 is already self transition. That is Q3 itself. Is what about 1? There's no any 1. So 5. And similarly there's no any epsilon path also. So 5. So like this now we have created now truth table. This is step number 3. Step number 2. Now step number 3. Step number 3 is, so we have to create another table with respect to epsilon closure. So we have to create another table with respect to epsilon closure and this truth table. So state input epsilon closure input output final epsilon closure output. Okay, state. So how many states are here now? 4 states are here. So you have to write each and every state. So we will start from Q0 now. So what about epsilon enclosure for input? So Q0, this is epsilon path, right? Q0, Q1, Q3. So we have to give the 0 and 1 for this state only. So we have to write these states. So only Q1, Q0, Q1 and Q3. So for this we have to apply the input 0 and 1. So 0, 0. And similarly for 1 also. So Q0, Q1, Q3. 1, 1, 1. Okay. So first you have to take the first state, and first state we have to check the which for Q0 what are the input for epsilon closure, that means epsilon path. So epsilon path is Q0, Q1, Q3. So that is Q0, Q1, Q3. So for each and every state we have to apply 2 symbols, because here 2 symbols are there, zeros and ones. So now this one. Similarly for next state Q1. For Q1 is, so epsilon path here is Q1, Q3. So Q1 and Q3. So for this Q1, Q3 you have to apply 2 input, zeros and ones. So Q1, Q3, 1, 1, right? So next state is Q2. So Q2 is, there is no any epsilon path but self transition there, epsilon to Q2. So Q2 itself. So for this you have to apply zeros and ones. 2 symbols. So if there are 3 symbol means, for example, if instead of this 0, 1, 2 means, here we have to apply 3 symbols also. So here 2 symbols only, that's why I am applying 2 symbols, zeros and ones, input symbol. So next Q3. Q3 is, so epsilon path is Q3, only self transition. So I am applying zeros and ones, the 2 symbols. So this is the table now. So this table we are created already with respect to this transition table and transition diagram and enclosure. So 3 of them is mixed with 1. So now we have to check the output. So what is Q0 of? If we are applying 0 to Q0, what is the output now? 0 to Q0, what is the output? Q0 is the output, right? Q0. And Q1 of 0 is Q2. And Q3 of 0 is Q3. Right? So Q1 of, so Q0 of 0 is Q0, Q1 of 0 is Q2, and Q3 of 0 is Q3. Okay, so next one is for similarly for 1. Q0 of 1 is 5, there is no any symbol there, and Q1 of 1 is 5, and Q3 of 1 is 5. And next one for Q1 of 0 is Q2, Q3 of 0 is Q3, and Q1 of 1 is 5, and Q3 of 1 also 5. Next Q2 of 0. Q2 of 0 is 5. Q2 of 1 is Q1. And Q3 of 0. Q3 of 0 is Q3. And Q3 of 1 is 5. Okay, so these are the output now. These are the output now. With respect to this output now, we have to check what are the epsilon closure output now. What are the closure output? So for Q0 we have to check what are the enclosure output, closure output, epsilon closure output. So for Q0 is, this is the output, right? Q0 is the output. So Q0, Q1, Q3. So what about Q2? Q2 is Q2. And Q3 is Q3. And similarly for Q0 of 5. So that's all 5. So 5 means same thing, 5. Represent 5. What Q2 is Q2. And Q3 is Q3. Epsilon closure output. And Q1 is 5. This is 5. And this 5. And here is also 5. Similarly for Q1 is epsilon closure. Q1 is Q1 and Q2. Q1 and Q2. And Q3 is Q3. 5 is 5. Okay. So this is a final table. From this table now we have to create a target truth table. Target truth table or transition table. Target transition table. Target transition table. So this is step number 4. Step number 4 is target transition table. That is, so 4 states are there: Q0, Q1, Q2 and Q3. And 2 outputs, zeros and ones. For zeros and ones, so for Q0 or 0, if you are applying input zeros, so what are the output now? So these are the outputs. So what are the output we are getting here? Q0, Q1, Q3 and union of Q2 and union of Q3. These are all union. Union means there is no any repetition. Without repetition you should write everything, right? So now you have to write everything. So Q0, Q1, Q2, Q3, right? This is the one. Sorry, Q0, Q1, Q2, Q3. And what about Q0 of 1? Q0 of 1 is 5. And Q1 of 0 is union of this Q2 and Q3. So Q2 and Q3. And Q1, that's Q1 of 1. Q1 for Q1 of 1 is 5. And Q2 of 0. Q2 of 0 is 5. And Q2 of 1 is Q1, Q2. And Q3 of 0 is Q3. Q3 of 1 is 5. Table I have discussed, we have discussed already now. So with respect to this table, we have created this transition table, target transition table. That is for Q0 for this is a Q0 state, this Q0 state. If you are applying 0 input, so what are the output you are getting? And we are applying this 1 input, what are the output you are getting? So this is the one. From this now we have to create on another transition diagram now. That's a step number 5. Step number 5 is, so now we have to create a final transition diagram. Final transition diagram. Transition diagram. That is, so with respect to this transition table, now we have to create the table transition diagram now. So how many states are there? Same thing. Q0, Q1, Q2 and Q3. Okay. So now Q0, if you have a Q for Q0, if you are applying 0 as an input, so where it goes to where? So Q0 goes to, so self transition Q0 is there. Q1, Q2, Q3. And next one is for Q0 of 1. So there is no any input signal, input symbol for 1, there is no any path. So that's a it symbol shows a null path now. Next for Q1. For Q1, if I apply 0 as an input to Q1, where it goes to where? Q2 and Q3. So for 1. for 1 goes to, for Q1 goes to, for Q1 if you go Q1, 0 goes to Q2 and Q3, 0. And for Q1, if you apply 1 as an input symbol, goes, there's a null path now, so no need to indicate that one. Next one for Q2 is a 0 is also null, and for Q2 1 is applied, you know, where it goes to where Q1 and Q2. So if you are applying 1 as an input to Q2, it goes to self transition 1 and goes to Q1 also. So Q1 also there 1. And for Q3 is self transition 0 and no input symbols path for 1. So this is the final, so this is the initial state now. This is the final state. Now you can see now. So here the now in NDFA, that means non-deterministic finite automata, its symbols they represent with the epsilon. So now actually ultimate goal here is we want to convert this diagram into without epsilon. So this is the one. This is the final one. So it's converted already. So you can see, so there is no any epsilon path here. So epsilon path, there is no any epsilon path. So Q0 here also 0 here. So there is no any epsilon path. So all are without epsilon path now. So it's created now. It's already created. Final step, there is a final step, step number 6. Step number 6 is, so here you can see here final state here. Final state Q3 is a final state. So final state is indicated or by double encircle now. So encircle is just that state represent final state. So how you can represent here now? So now we have to represent the final state here also. So step 6 represents with respect to the epsilon path. So for example for Q0, where it goes to where Q1 and Q3. So this is the epsilon path there. So epsilon path represent the final state now. So Q1, Q1, Q3. So Q0 and Q1 also, that is the final state. Q1, Q3 final state. And similarly for Q1, another epsilon path Q1, Q3. So already indicated, Q1, Q3 is already indicated. So this is the final state. So step number 1, so first you have to include epsilon enclosure. And step number 2, you have to create a truth table with respect to this diagram. Finally, step number 3, you have to create a table for epsilon closure output. With respect to this table, you have to create a target transition table. And now with respect to this target transition table, now you have to create a diagram, transition diagram. Now you can see now without epsilon, so epsilons are all eliminated now. So final step is, so we have to indicate the final state. So epsilon path, the states are all final state now. Okay, thank you.